In this video, we are going to go through installing version 0.3.0 of Frigate, and we'll talk a little bit about usage of the Frigate sensor coverage analysis tool. I've already installed the prerequisites, which are Z3 and Kind 2, both of which are free open source available tools. I can check that they're installed by running them from a command line and seeing that they provide some output. Then I'm going to launch MagicDraw from the MagicDraw bin directory. This is one of the simplest ways to make sure that the Z3 and Kind 2 binaries are available on the path for MagicDraw. I have already extracted the Frigate 0.3.0 release package, and what we're interested in for this video is the Frigate MagicDraw plugin. We will talk about the Frigate SimScape plugin in other videos. Once MagicDraw is open, I'm going to go to the Help Resource Plugin Manager. I'm going to go to Import and select the Frigate zip file. Then I need to restart MagicDraw. So now that Frigate's installed, first let's look at how we can confirm Frigate's available. I can do that by going to the Help Resource Plugin Manager, and I can see that Frigate 0.3.0 is now installed. What I can also see is I've got a new diagram type. If I go into Diagrams and Customize, I'll see a new diagram type under SysML Diagrams called SysML Goal Function Tree. Let's open up one of the examples that's included with the Frigate release. So in the Frigate release folder, we're going to go to Models, MagicDraw, and Sensor Coverage Examples. You might notice there's a new icon in the containment tree. This icon with 3 black rectangles is the Frigate Goal Function Tree package. That's a package stereotype that indicates to our tool that this package contains a goal function tree. This model is a goal function tree. This diagram is a goal function tree type diagram. So you can see this is a SysML goal function tree. When we open it, we have the Frigate modeling palette opens by default. So we have all of the goal function tree items available to us, such as the 3 different goals, the achievement, maintenance, prevention, the combination, operations, and or optional, as well as sensor, and then the system state constraint that we use to specify the parameters of a goal or the nominal condition described by a sensor. Let's do a real simple example now. I'm going to open up insufficient missing sensor. Open up the insufficient missing sensor Frigate goal function tree diagram. This has a single goal with an expression defining its constraints, which are the temperature has to be between 10 and 100. I can right click on it, go to Frigate, sensor coverage, check sufficiency. Frigate will run, and it tells me we have failed our sensor coverage analysis. I can hover over this. It'll tell me if your temperature is 0, that's a single counter example. If the temperature is 0, this maintenance goal will fail because 0 is outside of this expression, but no sensor is there to detect it. Let's look at a similar case that's working correctly, or I should say that's defined correctly. It's a similar situation, except now I've allocated a sensor to my temperature maintenance goal. Same goal, same state constraint, but now I have a sensor allocated that will provide some kind of alert if this state constraint is not met. So I can go frigate, sensor coverage, check sufficiency again, and now passes. Let's look at a little more complicated case. What if I have a sensor, but that sensor is not detecting all of the relevant conditions? Here I have the same temperature goal, and I have a sensor, but my sensor's state constraint is only checking for temperature less than 100. It's missing this case of temperature needing to be greater than 10. Let's see what happens if I run my sensor coverage again. Frigate says we have a problem. If I hover over, again, if temperature is 0, we're going to have a problem. My temperature sensor is only checking for temperature greater than 100. I can fix this in a couple of ways. The simplest is I can modify this state constraint expression. So I'm going to double click on my state constraint, go to tags, and I'll open up my expression. Oops. And I'm going to edit it. Like that. I'm going to save. And I'm going to rerun sensor coverage. Now we're all good. Let's try a couple different values. Ask yourself what's going to happen if I change this to 8. Now my sensor is checking for temperature greater than 8 and less than 100. My goal is looking for greater than 10 and less than 100. Oh, okay, frigate says if the temperature is 9, we're going to fail. And that makes sense, because 9 is less than 10, but greater than 8. Let's try something else. Let's try changing my sensor expression to between 20 and 100. I'm going to check sufficiency again. Frigate says this is fine. That's an important point to take away. The frigate tool is okay with false positive alerts. So we do not flag it as a problem if your sensor is going to report off nominal in a situation where a goal is still met. We are strictly looking for situations where unmet goals are not detected. Let's look at a little more complicated case now. Here I have two goals, one for pressure, one for temperature, and I have two sensors, one for pressure and one for temperature. I can analyze them all together by clicking on the AND conjunction and hitting check sufficiency, or I can check them individually by selecting individual goals. You might notice at the bottom this note 0 redundancy. That means that this configuration has passed sensor coverage, but if I were to remove any one sensor by going like that, it would fail. We can try that here. Now we failed the pressure portion of this goal tree. Let's look at an example where we have higher levels of redundancy. In this example, we have pressure and temperature goals, but now we have 2 sensors for each goal. So we passed the test, and now we report we have 1 redundancy. That means we can remove, or a failure can occur in any one of these 4 sensors, and we will still have sufficient coverage. Now, if I were to go in and delete one of these, like I did before, let's run again and see what it says. So when I deleted a sensor, it passed, but now we have 0 redundancy, meaning we can no longer be resilient to the failure of any one sensor.